m is an even integer and n is an odd integer, which of the following must be odd? Letter C is the first one to be discarded because such product is an even number, since 6 is even and m is even as well. So this cannot be our answer. Letter B is the second one to be discarded because we cannot determine what kind of integer is that quotient according to the rules. Remember that even over odd can be either an even integer or a rational number, a fraction. So this one is going to be discarded. Now, letter A is the third one to be discarded because here we have odd. A odd number power to 2 is a odd number as well, and odd plus odd equals even. So this one cannot be our answer because we are looking for the odd integer. Now, either letter D or E might be your answer. So I check letter D. 6 multiplied by m is an even number because both of them are even integers. M plus 5 multiplied by an odd number is as well odd. Finally, we get even plus odd, and according to the rules, even plus odd equals odd. So letter D is our answer. If the product x times y is negative and both are consecutive odd integers such that x is less than y, what is the value of y plus x? First of all, the problem states that x times y is negative. According to this fact, which of the following is true? Since the product is less than 0, then one of them must be negative and one of them must be positive. However, we don't know if it's this case or this case. Now, the problem states as well that x is less than y. Therefore, x must be negative and y must be a positive integer. This case is discarded. Finally, both x and y are consecutive odd integers. Which of the following numbers is a pair of consecutive odd integers? 5 and 7 is an example of a pair of consecutive odd integers. Another example might be -5 and -3. This is another pair of consecutive odd integers. Now, x and y are consecutive odd integers, but one of them is negative and one of them is positive. This is a number line. Here we have +1 and -1. This is the only pair of consecutive odd integers where one of them is negative and one of them is positive. Therefore, x must be -1 and y must be +1. And finally, y plus x must be 0. Alternative C is correct. If both x and y are each even integers, which of the following statements must be true? Number 1. Since we know that x and y are even integers, statement 1 is false because both products are even, and the difference between two even integers is always an even integer. Number 2. Statement 2 is true because such product has at least one even factor. This one is even, and even multiplied by any integer is always even. This one is true. Number 3 is false because the quotient of that division, even divided by an even integer, might be either an even integer or an odd integer, and we cannot determine this quotient since we don't know what numbers are x and y. So statement 3 definitely false. Finally, letter B is our answer. If x plus 1 and x plus 2 are consecutive integers, which of the following must be true? So first of all, if x is an even integer, then x plus 1 and x plus 2 are x plus 1 must be odd and x plus 2 must be even. Now, if x is an odd integer, then x plus 1 and x plus 2 must be so if x is odd, then x plus 1 must be even and x plus 2 must be odd. Have these two cases. So this is case 1 and this will be case 2. Now, from statement 1, x plus 1 times x plus 2 is even. So the product of two consecutive integers is always so the product of two consecutive integers is always even since one of them is even. Statement 1 is true. Now, statement 2, according to statement 2. X times x plus 1 times x plus 2 is not divisible by 6. So, we know that it can be either this case or this case. As you can see, the product of these three numbers must be even because at least one of them is even. Now, in a group of three consecutive integers, one of them must be so for any group of three consecutive integers, it is true that one of them is always a multiple of 3 or divisible by 3. Therefore, the product of three consecutive integers is always divisible by 6. Statement 2 is true as well. Now, statement 3. According to statement 3, 2 times x plus 1 times 3 is odd. Now, 2 times an integer is always so twice an integer is always even. Now, an even plus 1 is always an even number plus 1 is always odd. And odd times 3, which is odd as well, is always odd. Therefore, statement 3 is true. Finally, choice E is correct.